Hello there, welcome to lesson number 9 in our series on using FluidDesigner for 3D printing to create earrings. Today's lesson we're going to show you how you can create a Twisted Torus earring. So if you start up FluidDesigner, first thing we need to do is to go to Learning Projects, Jewellery Projects, Earrings. And we're doing lesson number 9, so you scroll down, so it's 09 and Twisted Torus. I'll just switch on the screencast key, so any key presses I make should be displayed down here. And this is the earring shape that we're going to create today. And we're going to have to use two objects. This is the main body of it is the Twisted Torus, and then there is this connector at the top where you would put a wire through to connect to your earring piece. How do we create the Twisted Torus? Well, as is usual, all the instructions are in the help window here. So it's add a mesh, torus objects, and it's a Twisted Torus. So if we go to add mesh, torus objects and Twisted Torus, this adds a torus mesh. And this properties panel here must be open for us to change these variables. But if we just go to view and zoom to selected, we'll see at the moment the torus is a rounded shape, and it's just 2.5 by 2.5 millimeters. So that's this external dimension. In the X, the red arrow is the X dimension, and the green is the Y dimension. So we need to change these values here, and in the help panel it tells us the major radius we want to change it to 10. It's currently at 1. So as you can see, as we increase that, the X and the Y values are increasing. We want a value of 10, so I'll just hold down the left mouse button and drag it, so you can see it's opening up the diameter of the object. I want 10. Oh, I've got it exactly this time. Normally you'll have to type in 10 there if you want it, if you want a particular value. So what have we got? What does the 10 tell us in relation to X and Y? Well, the bounding box excuse me, is 20.5 millimeters at the moment. So that's the dimension from the outside of the object to the outside of the object at the other side. So that's 20.5. Well, we've got a major radius of 10. Well, the major radius of 10 means the dimension from the center point to the middle point of the torus, so to this point here. So this is 10. And it's also 10 on the other side to the midpoint of the torus, so that's 20. So where does the 0.5 come from? Well, it comes from 2 times the minor radius, sorry. So the minor radius is actually the thickness of the torus itself. So 10 is the radius from there to the middle point of the object. 0.25 is the extra thickness, the extra radius here from the middle point to the outer point of the torus. So that gives you 10.25. If you double that, you get 20.5. And we can see that when we change the minor radius, we need to change the minor radius to 2.5. So as you can see, as I change the minor radius, it's increasing the thickness of the shell here. And we want 2.5. Probably not going to get it. Oh yes, we have got it exactly. That's quite unusual. Okay, so that's given us the thickness of the object now, and you'll notice the X and Y dimensions have changed because the major radius is the distance from the center point to the middle of here, that's 10, plus another 2.5 gives us 12.5 to the outer rim, and 12.5 on the other side gives us a total of 25 millimeters. So that's where this dimensions 25 come from. So we've set the major radius and the minor radius. Now we're going to change the major segments down to 5. At the moment it's 48. So I'm just going to hold down the left mouse button and drag the mouse right down, and you can see what's happening. So when we've put the major segments at 3 segments is 1 segment here, 2 segments to here, 3 segments. So it's the number of segments around the object. So if we change that to 4, we get 4 sides to this object. 5 will give us 5 sides. 6, 7, 8. Now clearly the higher this number, the more rounded the object looks. Okay, so we want to make it a very angular sort of shape. We just want a pentagon shape, so we've just got 5 major segments. Now the minor segments are the number of segments around the major segments. So the number of segments around here is currently 12. If I change that down to say 4 or 3, you can see what's happening. We've got 1 face there, 2 faces there, 1 face underneath, so there are 3 minor segments around the object. There are now 4, 5, 6. So you can see the number of faces are increasing here around the object, around this Twisted Torus. So we're going to reset that back to 12. And we've just got 1 twist. Now what the twist means is that if you follow a face around the object, it will twist and come back on itself. Okay, so that's the twist. Now we could change it, obviously, and as you can see it makes some quite weird and wonderful shapes as you change the twist. So all of these, it's possible to change them, but we're going to leave it at a twist of 1. So those are the changes that we need to make to our Twisted Torus. What we now need to do is to add this connector so that you can put a wire through here and hang it from your ear. Okay, so we need to add a connector. And we will find the connectors if we click on 3D templates connectors. We've already designed some for you. They're built into FluidDesigner, and there's a range of shapes and sizes, square ones, or cubic shaped ones, and rounded ones. We're going to use this one here, the 3x3 rounded one, and what we're going to do is to import that one and combine it with this Twisted Torus. Now if we simply drag and drop this Blender file onto the workspace, the work we've done here will disappear. So that's not the way to do it. What we need to do is to use a function called append. Append means we can take an object that's been created already and drag it into, append it to the current workspace. So we need to realize that we're going to 3D templates connectors, and so what we do is we select File and Append. So we're currently in Jewellery Projects Earrings, so we need to go up through the menu system. We're looking for 3D templates connectors, and we're going to do the 3x3x1 rounded one. And we're going to select Object and the connector 3x3x1. So it's the object that we need to append. Let me just go back up and do that again. So it's 3D templates connectors. We're going to do the 3x3x1 rounded connector, and we go to Object. So you always look for the folder Object, and it's the connector 3x3x1 rounded object that you append. And what happens there is that that object is dragged into FluidDesigner. It's appended to the existing work, and what we need to do now is we need to reposition this so that it fits at the side of the object. So the best thing to do here is to go to View and Top. Now we're currently in perspective mode here, top perspective. So if you zoom in on this, you can see we're not looking exactly on the top of this object, directly down on it. We're looking at it from a perspective point of view, so the object's disappearing to the distance. So what we need to do is we need to switch, we need to toggle from perspective to ortho view. That's a much better way of looking down on these objects. And sorry, I need to view it from the top again. So you can see we're looking on it now in a very sort of square way. Now in the previous one, the object was placed here. So I need to reposition this one. So I'm just going to drag it up there. Drag it to the left. Now what I need to do is I need to rotate this object around. The hole is there. So I need to rotate it about the x-axis. I need to rotate it about the x-axis. So if I go to view it from the top again. Now I can use the keyboard to do this. So if we press R on the keyboard for rotate. Now at the moment we can rotate it in all sorts of directions. I just want to rotate it about the x-axis, so I now press X on the keyboard, and that limits my rotation to the x-axis. So you can see it's just rotating about the red line, that's the x-axis. And normally you want to rotate 90 degrees, 180 or 270. So the best thing is to type in 90 and see whether that works. Now as you can see, it has rotated about the x-axis, but it's rotated it in the wrong direction for us. So we want to actually now rotate it 180 degrees. So we'll try that again. It's still highlighted, so it's R on the keyboard, X to limit the rotation about the x-axis, and type in 180. And as you can see, that's now rotated it so that the hole is on the outside of the object where we want it. And so we're almost there. So what do we want to do now? Well, we need to rotate it now to the left a little bit. So the axis that we need to rotate it about is the blue axis, which is the Z direction. So if I go to view and view it from the top again, and so this time what I want to do is to press R on the keyboard to rotate, and I want to rotate it that way, and the best way is to press Z to limit the rotational direction. So Z on the keyboard, that limits it, and this time I don't have an exact value like 90 degrees to rotate it. I'm just going to have to use my eye and just try and get it as square as possible with the current object. So I'm going to select that one. I'm going to select it there now, and I'm going to click the mouse button. So I've just had to use my eye there to square that up. Okay, so you can see my object now. And now we can reposition it. We can just use Y and Z to reposition it. So I'm just going to manipulate it around a little bit. Let me go view and top again. And position it until the hole looks like it's in a reasonable position. Now I've gone in a little bit further than I did with the original one, but that's okay. So view it from the top, see whether it looks alright. And it's always a good idea to view it from the left and see what it looks like. Now I think what we need to do is to get rid of this panel for the moment, and I'm going to get rid of, oh no, that's alright, I can't see the original here. So view it from the left and view it from the right, and just get a feel for what it looks like, and zoom around. There will be times when you need to adjust it vertically. Shouldn't be in this case. This object is centered on the this axis, and so is our connector, so that should be okay. So you just need to play around until you get it in the right position. So that's okay. I'm going to keep that as it is now. So what I need to do is I'm just going to delete the original object, so it's highlighted and X on the keyboard, and I just need to open up this properties panel now and highlight the original Twisted Torus, because what I've now got to do is combine these two objects together, the Twisted Torus and the connector, and we do that by going to the modifiers icon, and we're going to add a Boolean modifier. A Boolean modifier will join the two objects together mathematically. And just open up this panel. So at the moment I'm just going to switch into wireframe mode so you can see what's going on here. Here's our connector, and it's protruding into the object. What we've got to do is to join the two together. Now at the moment the option is to keep the part of the mesh that intersects with the other selected object. So in other words, only this area where they cross over would be kept if we use this option. We want to create a union, we want to combine the two meshes together, and the two meshes we want to combine together are the Twisted Torus and the connector. And when you do that, if this text is displayed here, it means that FluidDesigner should do its job. Now we haven't completed this at the moment. There are still lines on the inside of this object, so we need to apply this Boolean union, and we do that in FluidDesigner by going to Tools, Object Tools, and converting it to a mesh. And when FluidDesigner does that, what we should have now is one object where the Twisted Torus and the connector are joined together. But whenever we use Boolean, we always get a duplicate of one of the objects. So as you can see, we have joined the connector to the Twisted Torus, but we've also got an additional connector here, so we need to delete that. Now if we select the earring now, and if we go back to wireframe mode, and if I zoom in, you'll see that there are no internal lines now. The Boolean operation has deleted any internal faces inside this object, and we've now got a almost watertight object. And that's very important. That's what the Boolean does. We don't want faces inside. But it's still not perfect. We still need to go to Netfabb Basic and fix this. So first of all, we're going to save it. So File and Save As. Go up through the menu system and save it in Jewellery Projects Earrings as the Twisted Torus. So you save the Blender file. We can't print Blender files, so we need to export it, and we like to use Wavefront's OBJ format. And I'm going to export that to the desktop, so it's Lesson 09 Twisted Torus. And then we need to go to Netfabb Basic and Project and Open. So we go to the desktop and open the Twisted Torus. And as you can see that there are some issues with this mesh, probably there. That's what the warning red triangle is telling us. But if we go to Extras and repair the part, and just move Netfabb across so you can see what's going on. If I click Update, you can see there's one hole and there's some border edge problems. So if I run automatic repair and execute it and click Update, those problems have gone away. So we need to apply the repair and remove the old part. So the warning red triangle's gone now. So Netfabb's done its job, and all we need to do is to go to Part and export it as a Wavefront object, export it to the desktop as the Twisted Torus repaired, and that is now a printable file. Thank you, that's the end of this lesson.